caving community is they were told, okay, you have to pack everything out, and they would pack everything out but not know what to do with it when they got out. And you would think some things would be common sense, but for example, people were trying to recycle their pee bottles and maybe not like dumping them out and rinsing them, and so when the maintenance people would come upon them, it'd be pretty foul. So I think definitely like explaining it all the way to the finale of what you're supposed to do with it really helps. Energy usually have an active stream or river in them, like you can see in the background of my slide here. It's free-flowing water. We can have sediment banks and canyons underground, but in these environments, because we have an active stream that starts in the surface and goes underground, it's able to act as kind of like a conveyor belt. And what it does is it helps bring in nutrients into what would normally be a starved environment. Because unlike on the surface where we have sunlight and plants that photosynthesize to create energy and nutrients, underground it's dark. And so any nutrients that you find in the cave usually have to be brought in somehow. And streams provide one of these ways to bring nutrients into the cave. They also act as a conveyor belt to take stuff out of the cave as well. In caves where we have active streams like this, there can be a very short transit time for whatever the water brings in, because the conduits, which are bringing this water from the surface down underground, can be just like sewer tubes. You know, there's very little resistance or infiltration time, and so any pollution or nutrients that the rivers can bring in, they also can wash out of the caves fairly quickly. The second kind of broad category of cave environments I want to talk about, I'm calling low energy environments. And these are environments that have little to no flowing water in them. And that's not to say, I want to clarify, it's little to no flowing water. It's not to say that these caves are necessarily dry. A lot of times we do call them dry or paleo passages when we're exploring them, but you also have to remember that caves are often very humid environments. So there is a lot of water even in these caves that don't have flowing water, because the humidity is usually up around 99%. So a lot of times you'll get water condensating on the rocks and stuff, but there's not per se a flowing stream like you can see in this large chamber here full of big breakdown boulders. It's very dusty, and the wall, usually the condensation is on the walls. Caves are already what we call a starved environment. Once again, like I said earlier, we don't have sunshine to be converted through photosynthesis into energy, and so the microbes and biology that live in these caves have to do so in a very, very low energy environments, and are often called extremophiles because they live in such a starved environment. Within, saying all caves are starved environments, within that, these low energy passages in caves are even more starved because they don't even have the small amounts of nutrients that rivers and underground streams are washing in nutrients. They don't even have those. In these environments, the few nutrients that are used in these caves for life are actually metabolized from some of the rock. Sometimes you have hydrothermal activity in caves where it's bringing up sulfur that the microbes can metabolize. And then in some caves, bats or other animals that forage on the surface will go out on the surface and eat insects or fruit or whatever, and then come into the caves and defecate, and then that feces provides nutrients as well. Another thing about these environments is, like I said, in the high energy caves, the streams and rivers act as kind of conveyor belts for both bringing things into the caves and taking them out of them. In these low energy environments where there is no flowing water, there's very long to zero transit times. Anything that gets brought into these caves, either by animals or people, can be there for a really long time. part of that's kind of good for archaeology. A lot of our record of Paleo-Indians and whatnot is preserved because of these environments, but it also provides a challenge in that without sunlight or rain to help cause degradation of anything that gets brought in the cave, they're very sensitive to what people leave. Specifically, human waste impacts, I wanted to talk about. The main thing is introducing energy into these starved environments. Once again, like I said, because you don't have plants providing kind of the base of the food chain in these places, anything like a little poop or some dropped candy bar crumbs can cause these huge fungal blooms in the caves, where you'll have things that look like big hairballs that'll be growing on the ground just from a few peanuts maybe that got dropped. We want to avoid doing this because it ends up disrupting the microbial ecosystem, which I think a lot of times when we think of ecosystems, we think of big furry animals and trees and these sorts of things. But because caves are such a starved environment, I was introduced to this idea of microbial ecosystems, where caves have very unique flora of microbes in them that have learned or have adapted to these starved environments. And when you introduce a high amount of other material, there causes displacement in that community, where maybe someone that was creating energy that other microbes could metabolize gets to be a smaller portion of the population, because all of a sudden they're not the only ones providing nitrogen or carbon in that environment. Now all of a sudden you have this human waste providing that. I think we've already talked about a lot this weekend about how liquid waste introduces a lot of nitrogen to the environment, and specifically these extremophiles in caves. One of the main roles that a member of these communities, microbial communities, plays is fixing nitrogen from the atmosphere, and then they provide nitrogen for other microbes to then metabolize. And so if you're dumping like your urine into the cave, all of a sudden you have this greater proportion of nitrogen than was originally there, and the other microbes that are metabolizing it will, bloom and create very large communities. And then once they use up all of that nitrogen, there's a disproportion between the nitrogen, the microbes that were fixing nitrogen from the atmosphere and those that weren't. And then obviously human waste also introduces carbon in the environment, and it's the same thing. You have microbes that are pulling carbon from the rock, and instead now there's this new source. And this is one of the analogies. I don't know how much people worry about displacement of microbes on the surface, but one thing that I know that is important to us all is maintaining safe water supplies. And definitely in caves where you can have several miles of passage between water supplies, and sometimes a day or more travel time between these water supplies, maintaining their integrity is very important. And that's where managing human waste in these environments becomes important as well, because you can introduce bacteria and viruses into these water supplies. I'm just going to talk about two examples real quick where they think this might have happened, and I want to mention them both because it's kind of from two different causes. The first one is an area called Red Lake in Lechuguilla Cave, which is a 126-mile cave in southern New Mexico. And the water there, they didn't find anything growing it, but people in camp were getting very sick, and one of the problems they think was happening was they had kind of designated an area to go to dump your urine in, and it was, you had to walk from the where they were packaging their waste. You had to walk by the route to the water source back to camp. And one of the things that they thought might have been happening is people were having accidental spills or whatever in the bathroom area, and then tracking those microbes with their boots past where we got our water supply. And so one of the things that they've done to kind of mitigate that is now we have booties that we wear in the designated areas where we package our waste. And then also you can see the caver in this photo. We have a very specific water collection system, which is very low tech, but I think it works really well for hygiene in that we have a designated pitcher we leave in the cave, and you use that pitcher to get water, so it should be the only thing that touches the water supply. And then we have another designated area where you pour water from that pitcher into your personal water container that's past a little drainage area. So that way, if you pour water from the pitcher into the water bottle and some of it dribbles over the edge and picks up your bugs from the mouth of the bottle, that it's not draining back into the water supply. The second possible contamination we had in La Chiquilla I wanted to talk about is an area called the Pink Dot Pool. And what they think might have happened here is in the beginning of the exploration, they set up a camp and had an area where they were dumping urine in the cave, and a couple more years of exploration went on, and then next thing you know, they're finding this lake that happens to be hydrologically right below this dump site, and there was all this bacteria that was growing on it. And I know we talk a lot about urine being sterile, but I think a lot of times, people have accidents or it gets contaminated or whatever. And so one of the ideas with this, it hasn't been proven with the sampling or anything, but one of the ideas that might have been happening is, in caves, we don't necessarily know what we're upstream from all the time, because unlike mountains where you can have aerial photos and you can see where you're going, in caves we may pick a place to dump human waste and then a couple years later find passage that goes right under it. So that's kind of another unique problem, I guess, we have to manage. And I think probably, once again, something that all these have in common is just the aesthetics of leaving human waste in wilderness areas is not very appealing. It smells bad, it looks bad, especially, and this is something I think, once again, maybe we have in common with the river people, is we have really restricted corridors of travel. If you're in a hands and knees crawlway where you're crawling through something that's this big, and someone's had an accident in there and you have to crawl through it, it's fairly unpleasant. So I think just from the personal standpoint of not wanting to ever have to crawl through a mess in a restricted place, a lot of times motivates people to not leave waste in caves. And as I mentioned earlier, in some of these lower energy environments, solid human waste can degrade very slowly. The background of this slide is some paleo poop from Mammoth Cave National Park. These poops are between 2,000 and 4,000 years old. Yeah. Once again, great for archaeology. They could tell a lot about what the Paleo Indians going into the cave to mine were eating and whatnot, but it kind of puts in perspective of, in these environments, if you leave your number 2, people could be finding it in 4,000 years. Another problem that we've had in some of the sites and caves where we allow people to dump urine is staining. And even though after a few weeks and microbes have time to work on some of the urine in the dump spots, it won't smell anymore, but now the rocks have been stained. And this is something that we even see biologists use it to identify bat colony locations, for example. Bats will hibernate in caves during the winter, and sometimes you'll want to look for places where bats stay during the summer. And one of the things you can identify these places where you'll have hundreds of thousands of bats congregating in the same spot in the cave is all of the walls and ceiling of that chamber will be coated in kind of a patina that is from all of the bats defecating there. And in these pea spots that we allow in some of our caves, we're kind of seeing the same buildup of a patina where we're dumping. And then, as I mentioned earlier, fouling routes, the whole constricted corridor thing. So as far as management strategies, Mammoth Cave is kind of considered one of these high energy environments in their lower passages. And so one of the things that the park allows is digging cat holes in the cave. Mammoth Cave is over 300 miles long, and they're not allowing visitors that take the cave tour to cat hole along the tour route. But we all have scientists and cave surveyors and explorers that are usually having about 6 expeditions a year. Those expeditions usually field about 50 people. And so if you spread those people out over 350 miles of cave, it's fairly low impact, especially a lot of these passages, they may map it to the bitter end where they can't crawl anymore, and no one will ever probably go back there again. One of the things that they do ask about the cat holing is, like I said, we had those paleo poos that I said earlier, thousands of years old. And so in the cultural areas of the cave that are drier, they don't allow you to cat hole there. Once again, this is along the streams. I was highly amused by the river presentation this morning, where afterwards we had a discussion of how many cubic feet per second a river needs to be in order to pee in it. And when it comes to caving, if there's a trickle, so can we. So, as long as there's moving water, a lot of times, we prefer to pee in the water, because a lot of these caves, if you pee in the dry areas, it lasts for a really long time, and because of the constricted environment of it, it doesn't necessarily air out very well. So definitely in the active stream areas, like I said, as long as there's flowing water, and I think maybe we get away with that because, like I said, we are a more, dispersed use group, so. And yeah, so we're more low visitation. Oops, wrong way. And I kind of mentioned this at the beginning of the talk, but something that I think maybe is unique to caves as well is I think a lot of the wilderness areas that have been talked about so far during the conference are at the tops of watersheds. They're at the peaks of mountains, the beginnings of glaciers, and this sort of area. And so if there's any outbreaks of E. coli or viruses or something, then immediately the first group that you think of are the hikers or the climbers or the mountaineers. But a lot of times caves are downstream of urban centers and agricultural use. And so the high E. coli levels aren't always our fault. Many karst aquifers, which karst is a term for landforms that have caves in them, a lot of times they're contaminated because, like I said, there's direct routes from the surface into these waters. For example, there's been testing in the Ozark Aquifer that has elevated estrogen levels, and I don't think there's enough of us girl cavers out there running around that's our fault. There's some caves that, like I said, have the elevated E. coli, and a lot of times this is because of not the recreational users in the caves, but because of activities on the surface that happen to be upstream of us. And one of my favorite examples of this is, I think it was a Popular Science article from the 1920s that said, "Move to Bowling Green, Kentucky, the only town with a natural sewer system." And what they were referring to is a cave that underlies the whole city, and some people were actually straight piping their home toilets into the cave. So, I don't know how many of you guys are having to deal with that, but that's probably a little unique for us. With other management strategies within the Park Service, I wanted to talk about wind and jewel cave, and this one's really simple. These caves have no flowing water in them at all, and so they're completely low energy environments. They're both over 100 miles long, and their policy is just to pack it all out. That's all urine and all number 2s that you do in the cave have to come out with you. A third very long cave we have in the Park Service, Lechuguilla Cave, I mentioned earlier, is about 126 miles long. And it's also a low energy environment like Jewel and Wing Cave, no flowing water. And for any trip that's less than 48 hours, they require you to pack everything out. But they diverge slightly from the policy of the caves in the Black Hills of South Dakota in that if you do a trip over 48 hours, they have 4 camps, and each of those camps in the cave have a urine dump site, and you're allowed to dump your urine there, but you still have to hike out your solid waste. And definitely dumping urine is not an ideal situation in these environments. Like I said, it restricts how frequently camps can be used in the cave. And they're stating that it occurs, you're introducing nitrogen. But there's some difficulties that I'm going to talk about on why there's a divergent of policies in the Park Service on these caves. The first one is a difference in logistics. Wind Cave and Jewel Cave are both what we call horizontal caves in that they don't require any climbing gear to negotiate the, hundreds of miles of passage in them. Whereas Lechuguilla Cave is the deepest cave in the contiguous U.S. I think it's 1,600 feet deep, and so there's a lot of vertical work required in it where we're rappelling down static lines and using mechanical ascenders to ascend. So with that added weight, one of the arguments is, if you're camping in the cave for 8 days, that's a lot of urine to haul out in addition to this ropes and heavy metal for climbing. Second difference between them is the caves in the Black Hills have stocked camps. The park has sleeping bags, sleeping pads, and stoves in the camps that if you fill out a permit to use the camp, then you use that material and you're not having to carry it through the cave. Whereas Lechuguilla has 4 camps, but none of them are stocked. So in addition to your ropes and hardware, you're also going to be carrying your sleeping bag, your stove, and your sleeping pad. And still, I think relatively to a lot of the mountaineering packs, we try to keep it light because we're having to crawl through small spaces with these packs. So you don't want like the massive external frame pack on your back when you're trying to go through belly crawls and having to pull that behind you. I think on average, the Lechuguilla camp trips, we try to keep our packs between 35 and 45 pounds to kind of give you some reference there. Also, a difference for the policies that was cited was a fear of dehydration. I think it's just natural behavior. If you're told you're going to have to pack out all your urine, you're not going to be chugging Mountain Dew all the way into the cave because you're going to produce a lot of piss to carry out then. And so one of the things that they cited is in Lechuguilla, the cave's about 12 degrees warmer than the cave in the Black Hills because it's further south in the U.S. And caves are, the temperature in caves is usually the average temperature in that area. And even though it's only about 68 degrees and that doesn't seem that warm, you're climbing ropes in 99% humidity. And so because of that, you're sweating a lot, and they were worried if they had people on the trips that were over 48 hours long be required to carry their urine out, they'd have more incidences of people being injured due to dehydration. Another difference is the length of camps that are allowed in the two sets of caves. In the Black Hills, you're limited to a 4-day camp, and in Lechuguilla Cave, they allow 8-day camps. And so, as you can imagine, it's a lot easier carrying out 4 days worth of urine than it is 8 days worth of urine. And finally, and this kind of will segue into, I think we're talking about behavior after this. I think also the camps in Lechuguilla Cave were established before those in the Black Hills, and when they were established, they were allowed to dump. And I think it's harder to talk to people into carrying their urine out now that they've been allowed to dump it for 20 years. Whereas the Black Hills caves, the exploration was much slower, the passages are much smaller, so it's taken longer to get far enough out in the cave where you need to have camps. And since, you know, the 30 years it took to get far enough out in those caves to have a camp, you weren't allowed to pee in the cave, that people had no problem being told you have to have, you can only stay in the cave 4 days when you can't because you have to carry all of your urine out. I already mentioned in caves that have active streams, we allow urine to be dumped there. In low energy caves, like I said, we do allow a few dump sites in Lechuguilla Cave. They're good because we limit the impact to the cave to a concentrated area. Unfortunately, they do require about 2 weeks between use. What we do when we camp in Lechuguilla is we store all of our urine up in big plastic bags, and we don't dump it until we're heading out of the cave, because you don't want to spend a week in camp where you've been dumping piss. Also, like I had mentioned before, the possible contamination of the pink dot pool is sometimes we pick these dump sites not knowing if there's cave passage under them. And then we also, and preventing contamination that happened at Red Lake is we require you to wear booties when you enter these dump sites, and then you take them off as you leave to hopefully prevent tracking of whatever bacteria and nasties are in the dump sites out into the trail and then back to camp and the water sources. For solid dump sites, I don't know of any designated concentrated like digging trenches in caves, but like I said, in Mammoth Cave they do allow cat holing. Usually it's acceptable if you have these stream passages in the cave. One problem that I know an exploration group in Virginia was having is they would bury the cat holes and the feces was breaking down, but the toilet paper was still in there, so they started digging cat holes and then using toilet paper but burning it when they were done. And like I said, there's no dump sites allowed in the low energy caves. Because we do have to haul our urine out in sometimes some arduous passageways, as you can see the cave on the back of this slide, there's lots of considerations that have been taken into containers for carrying your urine while you crawl through a cave and throw your pack around to get it through crawls and accidentally drop it and these sorts of things. There's always an argument between having a hard versus flexible urine storage container. The argument for the hard containers is that they're more durable. You don't have to worry about them leaking as much, but they take up more room. I know a lot of people that use like the platypuses, and you know, that way, you know, you're trying to keep your pack small so you can fit it through small areas, and that way the bottle is as small as it can be until you start using it. Also, the whole disposable versus reusable storage containers. A lot of people I know just they drink a Gatorade and they keep the bottle and they pee in the bottle and then they throw it away when they're done. Other people, like I said, if you're using these flexible bottles, then they're reusing those. There's also some sort of mini carboy type QB things. They're about 1 liter in size, and they're kind of multiple use. I heard you can get about 5 uses out of them before they start leaking. And then also for those of us with full sets of chromosomes, we usually have to think about funnels and wide mouth bottles because the little pop lids aren't big enough. Also, like I said, at these dump sites that we have to store the urine for about a week, and the two things that have been most popular in storing the urine are just like the big 2.5 gallon Ziploc bags, or the wine bags that you get if you buy wine in a box. Those seem to work really well. And this is a photo of one of the urine dump sites, and in the foreground, there was a pointer, wasn't there? This way. In the foreground here, you can see that we have our paper booties that we wear. So you'd hike up here, you'd put the booties over your boots, and then you go back here, and we have plastic bags for storing the urine here, and then the dump site's right behind the ledge over here. So you store the urine, and then you come back out here and you take the booties off, and then we found that a lot less people were getting sick at our camps if we just provided a huge bottle of hand sanitizer at the restroom area, and it cut down greatly the number of people that were having diarrhea issues and stuff while we were camping by just providing that. Solid waste transport. Caves are such a harsh environment. We usually try to keep things as low tech as possible, which I hear a lot of you saying about the alpine areas as well. And I think the river presentation also talked about, you know, this community trying to do things inexpensively, and we make what we call burrito bags, and pretty much all you do is you put down some aluminum foil, you do your business, you roll up the burrito, and you put it in the bag. It's really inexpensive. The park's now trying to get people to use drop cloths though, because even with a square foot piece of aluminum foil, people tend to be missing and stuff. So, and then also there's all those manufactured options that everyone's been talking about, and those are becoming more popular. Some people put it in a hard container to take it out. The problem with hard containers and cave packs is, once again, we're dragging our pack a lot, and if you have big corners, your pack gets stuck a lot. So a lot of people just kind of triple bag it, and try to pack it carefully. And I was glad to hear that a lot of other people are talking about what you do with these packed out containers. It sounds like, Shasta and Rainier and stuff are talking about having specific receptacles, and that was just one point, I wanted to make, not knowing if people were doing that or not, because I know problems we've had with the caving community is they were told, okay, you have to pack everything out, and they would pack everything out, but not know what to do with it when they got out. And you would think some things would be common sense, but for example, people were trying to recycle their pee bottles and maybe not like dumping them out and rinsing them, and so when the maintenance people would come upon them, it'd be pretty foul. So I think definitely like explaining it all the way to the finale of what you're supposed to do with it really helps.
I had a question about the illnesses at was it the Red Cave site?
Yeah, there was a Red Lake was
Red
the
Lake.
campsite where people were getting sick.
And you were collecting water, were you treating water?
No, unlike some other karst aquifers, the Lechuguillo water is up on a plateau where there hasn't been any human development, and so people weren't treating the water because it had been tested and hadn't had any problems with it. So before that time, they hadn't been treating it, and still to this time, they don't usually treat the water, because as long as we're being very particular, like I said, we have like these booty sites and stuff, we haven't had any more problems.
So what are they checking it for, do you know?
I don't. I should actually probably explain. I'm not one of the managers of the caves in the National Park Service. Stan Allison was the original person that wanted to give this talk, but he couldn't travel up here. So as a user and a fellow Park Service employee, he asked me to give the presentation. But if you wanted to contact Stan, and I can give you his information, he could probably tell you what they were testing for.
Okay.
I wanted to ask you a little about the stocked camps where NPS is providing gear for visitors. We heard a little bit in last night's presentation about some of the concern in pack-out system and shared tents. I'm just wondering if there's any hygiene issues with those sleeping bags, whether they use liners or not, or.
Usually people pack a liner in to use them, but with those stock camps, you're probably they're 6 to 4 person camps, so you only have 4 to 6 people staying there, and their frequency of use is probably only about 6 times a year. So I think, if they were more highly used, maybe it'd be more of an issue, but I haven't heard of any problems with it so far. With those camps, a lot of times there can be a month or two between uses. So.